Okay, so everything we've learned so far has resulted in a perfect square. So when we got to our final answer, it ended up being a perfect square and it was easy to solve, to write our answers. But that's not always going to be the case. So we need to learn how to deal with a solution that's not a perfect square. So that's where simplifying radicals come in. We are going to go back for a minute to chapter 6 when we were learning how to simplify radicals. If I gave you something like the square root of 3 times the square root of 6, we learned that that was the square root of 18. So now we're going to kind of go backward. Instead of saying the square root of 18, we can break that up and say, well, 18 is the same thing as 2 times 9. And we know the square root of 9 is 3. So I can change this to say the square root of 2 times the square root of 9, which would be 3 times the square root of 2. And that would be simplified as far as you can in simplest radical form. So if you're multiplying two radicals, you can multiply them inside the radical. Now, if you're taking the square root of a fraction, you can break that up into the numerator and denominator. So the square root of a over b is the same thing as the square root of a over the square root of b. So where that can be helpful is if you had, and I think we've already done this actually, the square root of 25 over 3, we know that that's 5. I'm sorry, let's make that 25 over a perfect square, like 9, and that would be 5 over 3. So we would have 3 here. Okay, and now that means it's the square root of 25 over the square root of 9, which is where we got that. All right, so that's what we're going to be doing today. So let's move on to some questions here. If I wanted to simplify the square root of 32, it's not a perfect square. So we are going to break it down into its roots. What we want to do is try to find the largest perfect square that's divisible. We can divide into 32. In this case, 16. 32 is the same thing as 16 times 2. Okay, and I know the square root of 16 is 4, so I can rewrite this as 4 root 2. Okay. For the next one, square root of 9x cubed, we can break that 9. 9 is a perfect square, but we can break the x cubed into x squared times x. What we want to do is find the largest even number that we can take out. Since x cubed is the same thing as x squared times x, we're going to split it like that. X squared is a perfect square because it is an even exponent, and 9 is a perfect square. So this would become 3x root x. Square root of 9 is 3. Square root of x squared is x. And x is alone. It's left behind. It's not a perfect square, so it has to stay inside that radical. Then we have over here some fractions. Okay, as I said before, we could break it up into the numerator and the denominator. So for the first one, let's change colors here. We can say the square root of 13 over the square root of 100. Well, the square root of 13 cannot be simplified any further. 13 is prime. There's no perfect squares that go into it. So we're going to leave that as the square root of 13. Square root of 100 is 10. Before we move on, just want to mention real quick, I know we talked about this many chapters ago, the square root symbol that we keep using refers to the positive value. Okay, so if they're using that symbol, they're asking for the positive value. If they want the negative, they will have to ask us to negate it. If they want both, they will have to ask us for both. Okay. All right, moving back to this. So here we have the square root of 7 over x squared. We can simplify that into the square root of 7 over the square root of x squared. So in the numerator, we still have the square root of 7. We cannot break that down any further because there's no perfect squares that go into 7. Okay, other than 1, but 1 doesn't help. The square root of x squared would be x, and then you have your final answer in simplest radical form. Okay, so let's practice a couple more. If you want to pause this and practice them on your own, you're welcome to, and then just press play when you're ready. Okay, so square root of 24. We can break this up a few different ways. Let's look at it a couple different ways. We can say that's 2 times 12, right? We can say that is 6 times 4. Let's look at it both ways here. If I say 2 times 12, that's fine, but neither of those are perfect squares. So we're going to have to break 12 down a little further. So we would say 12 is 2 times 6. Well, we could say 2 times 6. That's not really going to help us much, other than we can see here we have 2 2's. So that's the same thing as 2 squared times 6. And 2 squared is 4. So either way, you're going to end up with the same answer. Square root of 4 is 2, and we're left with a root 6. Okay. The next one is a perfect square. 25 is a perfect square. X squared is a perfect square. So we just get 5x. Okay, whenever we have a radical in the denominator, that is not rationalized. We always need to make sure our fractions are rationalized. And what that means is we need to get that denominator, we need to get that radical out of the denominator. The process is called rationalizing the denominator. So we can't change the value of the fraction. So the only thing we can multiply by without changing the fraction is 1. So we're going to multiply by an equivalent of 1. One way to get rid of the denominator is to make the denominator a perfect square. So if we multiply by the square root of 7 over the square root of 7, that will turn our denominator into a perfect square, which we could eliminate the radical. But make sure we do that to both the numerator and the denominator, because remember, we have to only multiply by an equivalent of 1. So I'm not changing the value, we're just writing it in a different way. Okay? So our numerator, we're going to say 5 times root 7, which becomes 5 root 7. And our denominator becomes root 49. 7 times 7, which is 49. And the square root of 49 is 7. So we're going to be left with 5 root 7 over 7, which is rationalizing the denominator. Okay, so no radical in the denominator. Never leave it with a radical in the denominator. If they ask you to simplify and you have a radical in the denominator, it's not simplified. Okay, it's an important thing you want to write down before you go to geometry next year. Okay. All right, so the next one, this is not rationalized. So we're going to multiply by root 3b over root 3b. So the numerator becomes root 2 times 3b for root 6b over the square root of 3b times 3b, or 9b squared. And when I take the square root of 9b squared, I'm just left with 3b. And now I'm completely simplified. We cannot divide the b's because one's inside the radical. They're not common factors to be able to simplify. The 6 and the 3 cannot either, because in the top, the numerator is stuck inside that radical. So we can't break it up any further, unless we could simplify that 6b, which we can't. We could break it into 2 times 3, but neither of them are perfect squares, so they're still stuck inside. Okay, so when we're solving quadratics, sometimes we're not going to be left with a perfect square. So we need to be able to rationalize, simplify, write them in simplest radical form. Sometimes they'll ask you just to round your answer. When you get to your HRW homework, you're probably just going to have to round your answer, and that's fine. Just plug it into a calculator when you're done. If you need help with that, I'd be happy to show you, but I think we're okay with that. What I want to focus on is simplifying the radicals. Okay. So for this one, you can subtract 90, divide by -1, but I'm just going to bring the x squared to the other side. So we would have x squared equals 90 if we add x squared to both sides. So then we've isolated the radical, the square. So now we can take the square root of both sides. Don't forget, if we're taking the square root of a square, it leaves us with the absolute value. And over here we have root 90. Okay, so now remember, to undo the absolute value, we have positive and negative, root 90. But 90 can be simplified. So let's break it down to its perfect squares. The largest perfect square that's going to go into 90 will be 9. We could break it up into 9 times 10. Square root of 9 times 10. Don't forget, it's positive and negative. So 10 can't be simplified any further, but 9, square root of 9 is 3. We have positive and negative 3 root 10. So 10 can be broken into 2 and 5, but neither of those are perfect squares. And if you're writing them in set notation, always write it from least to greatest. Negative 3 root 10 and positive 3 root 10. Okay, so the next one, I am going to start by dividing by 2. Everything is even. Let's make it a smaller, simpler equation. Let's just divide everything by 2. So we have x squared minus 32 is equal to 0. Okay? When you isolate that x squared is equal to a positive 32. Take the square root on both sides, so the absolute value of x is root 32. 32 is not a perfect square, so we're going to have to break that down. But let's go ahead and isolate that. Get rid of the absolute value first. So x would be positive or negative. Okay, so now let's simplify that. 16 goes into 32 2 times. So it's going to be positive or negative 4 root 2. Negative 4 root 2 and positive 4 root 2. I think we have a word problem coming up soon. Oh, I got it. Okay, so here when we subtract the 45, look what happens here. We're going to end up with a negative over here. If you remember, if you take the square root of a negative, it becomes an imaginary number, which you haven't learned yet. You're welcome to go research that if you want. Otherwise, you'll learn it in Algebra 2. But there is no real solution since we can't take the square root of a negative. At least can't get a real number. Okay, word problem. The house is on a lot that is shaped like a trapezoid. The solid lines show the boundaries where x represents the width of the front yard. Find the width of the front yard. So we're trying to look for x. That's what we're trying to get in the end. Given that the area is 6,000 square feet, round to the nearest foot. Okay, so in this case, we're going to use a calculator. They're going to tell us to round, but we're not going to do that until the very end. Always round your very last answer. You want to be as accurate as possible. So the area they've given us is 6,000. We can see here that the height is 2x. The height is just the distance between the two parallel bases. So the height is 2x. And then base 1 and base 2, those are your parallel sides, 2x and x. Okay, so let's simplify what we can here. Let's see, we have 6,000 is equal to, well, 1/2 of 2 is just 1, so we can make that x. Inside we have 2x and x, which is 3x. So we have 3x squared is equal to 6,000. If I divide by 3, x squared is 2,000. Now I'm going to take the square root, and I know that the square root of a square is the absolute value, but in this case I'm going to ignore the negatives because we can't have a negative side length. So we're only going to look at the positive answer. When you plug it into your calculator, be mindful of the calculator you're using. Some of them you have to write the square root symbol first, and others you put the number first and then hit the square root. So I get 44.721359. That's what fits on my calculator. I said to round to the nearest foot, so we're going to look at this number, and it's approximately 45 feet. It's not an exact value, but it's an approximate value.